Last time, we explored how datasets are the foundation of machine learning models. But what happens when these foundational datasets are not truly representative? This is where data bias comes in. Data bias refers to systematic errors in a dataset that lead to unfair or inaccurate outcomes. It's not about individual data points, but patterns of skewed representation. Understanding and addressing data bias is crucial for building fair and reliable artificial intelligence systems. One common type of data bias is called selection bias. This occurs when the data used to train a model does not accurately reflect the real-world population it's intended to represent. For instance, imagine collecting data for a health application primarily from younger individuals. If this data is then used for the entire population, the model will likely perform poorly and show bias. The selection of who provides data directly impacts the model's fairness and accuracy. Beyond who is included, bias can also creep in through how data is reported or measured. A reporting bias happens when certain outcomes are more likely to be recorded or emphasized. Think of surveys where people give socially desirable answers. Measurement bias refers to systematic errors in how data points are quantified or observed due to faulty sensors or subjective interpretations. Both types lead to skewed datasets, making models learn an inaccurate reality. So, why does data bias matter? The impact extends far beyond inaccurate predictions. When models are trained on biased data, they learn and perpetuate those biases, leading to unfair or discriminatory outcomes. Imagine a hiring algorithm preferring male candidates because its training data predominantly featured successful men. These models can reinforce societal inequalities, making ethical considerations paramount for artificial intelligence. Detecting data bias is the crucial first step towards building fairer artificial intelligence. This often involves statistical analysis of our datasets. We examine the distribution of sensitive attributes like gender or ethnicity to see if certain groups are underrepresented. We also compare outcomes across different groups to identify disparities. For example, does a dataset show one demographic group consistently receives lower scores? Specialized fairness metrics help pinpoint where bias exists. Once bias is detected, the next challenge is mitigation. Strategies include data rebalancing techniques, like oversampling underrepresented groups or undersampling overrepresented ones to create a more balanced training set. Data augmentation can also generate synthetic data. During model development, we can incorporate fairness constraints that encourage equitable predictions. Ultimately, mitigating bias requires thoughtful data collection, continuous monitoring, and a commitment to building fair and accountable artificial intelligence systems. In summary, data bias is a multifaceted challenge that requires vigilance at every stage of the machine learning pipeline. By identifying and mitigating these biases, we move closer to the goal of truly ethical and fair artificial intelligence. Thank you for watching, and remember to build responsibly.